Okay, so we're back here for part 2. So now actually let's get into solving each equation by completing the square. So we're here in part B. Here's the equation. Now, I would always try to factor this first. If I can factor it, that's going to be the fastest way. But sometimes we don't recognize a factor pattern right away, or sometimes there is not a factor pattern. It cannot be factored. So one option would be to try to complete the square. When we want to factor it, we need everything on one side equal to 0. If I was going to complete the square though, I would keep my x terms, my x squared and my x term, on the same side. And I would move the positive 55. I'd move the constant to the other side. So what I'm going to do is I'm going to subtract 55 from both sides. And we get x squared minus 16x equals negative 55. Now we wouldn't try to factor it now because I could take an x out of this, but I can't do it from here. So factoring is going to be a mess. You'll notice I left an empty space right here. What we would like to do is take this problem and change it into a perfect square. So can we take this, and I'm going to think, what could I add to x squared minus 16x that would make this a perfect square trinomial? Well, we would divide by 2. We're going to complete the square. That's negative 8. And when we square that, we get 64. Okay, now here's the catch. I can't just add a number to one side of the equation unless I do it to both sides. Remember that equals means balance. The left and the right have the same value. So if I add 64 to the left, I have to add the same thing to the right. So I am going to add 64 also to the right side. See, if I were to take this away now, I would be right back to where I started. Okay? Now the reason we would do this is now a perfect square trinomial. That is, we can write that as x minus 8 squared equals, and then we would add here, and that gives us positive 9. Now this is actually really nice. We have a perfect square here with the variable. So we'll take the square root of both sides. The square root of x minus 8 squared. The square root and the square undo each other. We get x minus 8 equals. Now the square root of 9 is also nice. It would be plus or minus 3. All right, remember there's two values that we can square that would give us a positive 9. It could be a positive 3 or a negative 3. All right, the last thing to do here is to solve it. We would go plus 8 on both sides. Now I'm going to write this as x equals 8 plus or minus 3. So our two answers, and it doesn't matter if you do, say, 8 plus 3 and then 8 minus 3, or if you do 8 minus 3 first, we end up getting 11 and 5. Those are our answers. If I write it as a solution set, I'll put the 5 first because it's smaller. Now, as with any equation, we should check and make sure it actually works. If I take 5 and go back to the original problem here, 5 squared would be 25. Minus 16 times 5 is negative 80. That would be negative 55 plus 55 is 0. That actually works. Okay, so this is a solution. If I tried positive 11, I would do 11 squared, which is 121, minus 16 times 11, which is 176. That's negative 55 plus 55 would be 0. Okay, so both of these are good. All right, let's try another problem. Let's take this one. Now, 11 is actually set up very nicely because we already have the constant on the right side. So we'll think n squared plus 2n plus something equals 8 plus the same something. Remember, we have to add the same value to both sides to keep the equals good. All right, so let's see. We want to make this a perfect square trinomial, so we're going to complete the square. Half of 2 is 1, so it would be like 1n and 1n for our middle terms. Now if we square 1, we actually just get 1. So we're going to add 1 to both sides. We can now factor this. It is n plus 1 quantity squared, that whole thing, equals to 9. And now we solve it by taking the square root, n plus 1. Again, that's plus or minus 3. And then we can subtract 1 from both sides. So now we get n equals, this is negative 1 plus or minus 3. So that would be negative 1 minus 3, negative 1 plus 3, and we get negative 4 and positive 2. And there we go. Let's take a problem, let's go ahead and take 13. Again, the setup is nice. Plus some number equals 12. Plus, that's a 12 there, plus the same number. All right, so let's see, complete the squares. So divide by 2, that's negative 4. Square it, we get 16. But if we add a number to one side of the equation, we have to add it to the other. Same thing. This is x plus 4 squared. Oops, sorry, not plus 4. That is a minus 4, because this is negative. X minus 4 squared, to get us that middle term, equals 28. Now with the variable here, that is a perfect square. So we'll square root both sides. This is x minus 4, that's nice. The problem though is that this is plus or minus the square root of 28. That's not a perfect square. That's some decimal. But we can simplify this. So in this case, we have to simplify. So think about a perfect square factor of 28. Now if we think of 28, that is 4 times 7, where 4 is a perfect square. The square root of 4 is positive 2. So we get x minus 4 equals plus or minus 2 square root 7. The 7 will stay under, but the square root of 4 I can evaluate. That becomes 2. Now plus 4, and we get 4 plus or minus 2 square root 7. Now we can't add this. It's not 6, it's not 4 minus 2, because this radical is like a variable. The 4 does not have a square root 7 attached to it, so I cannot add it here with the 2 square root 7. Those are not like terms. So I can actually leave it like this, or we could write 4 minus 2 square root 7, and then 4 plus 2 square root 7. We could do that. Okay, so not every number or not every problem can be factored, not every quadratic. This is a case where if we tried to factor this the way it was set up, we wouldn't be able to solve it. So this is where completing the square is nice, because this technique will always work. Factoring may not always work. All right, let's take number 15 here. If we want to complete the square, we would need the variables to be on the same side. So I would move negative 9x, and we would get x squared plus 9x plus something equals negative 14 plus something. All right, so we want to complete the square to make this. Our goal is to get a binomial squared. That's what we're trying to do here. So we would divide by 2, 9 halves. Now if we square that, we get 81 over 4. 9 times 9, 2 times 2, so plus 81 over 4. This is x plus 9 over 2 squared equals, now adding fractions, I would write that as negative 14 over 1. I could multiply these by 4. So negative 56 over 4 plus 81 over 4 is 25 over 4. And now we take the square root of both sides. X plus 9 over 2 equals, now this is actually a perfect square, I can take the square root of the numerator and denominator, 5 over 2. But remember, there's two solutions, so we write plus or minus. Move the 9 over 2 by subtracting it. So we get x equals negative 9 over 2 and plus or minus 5 over 2. All right, so that would be negative 9 over 2 minus 5 over 2, comma. And then the other solution, negative 9 over 2 plus 5 over 2. We can actually combine the numerators here because we have the same denominator. This would be negative 14 over 2. This would be negative 4 over 2. And we would get negative 7, comma, negative 2. Two solutions to that. All right, that is the end of part 2.